Okay, let's wrap this up. So, an electric motor lifts an elevator 9 meters in 15 seconds by exerting an upward force of 1.20 times 10 to the 4 newtons. What power does the motor produce in kilowatts? Okay, let's figure out in watts and then we'll go to kilowatts. So, power is work over time, and work is force over displacement, or multiplied by displacement. And we have all that info. We have 1.20 times 10 to the 4 newtons as our force. This happens over 9 meters, and it's done in 15 seconds. Okay, run those numbers. So on the top of our fraction, we have 1.2 times by 10 to the 4th. Okay, multiply that by 9, divide it by 15. 200 watts. Now, 3 sig figs, 3 sig figs, 3 sig figs, 2 sig figs. We actually need to write it in scientific notation. 7.20 times 10 to the 1/3 watts, but we need it in kilowatts. Okay, so we have 7.20 times 10 to the 3rd watts. We want kilowatts, and every kilowatt has 1,000 watts in it, so that means we're going to be dividing, which leaves us with 7.20 kilowatts. Nice. And then our last example problem. Luigi lifts a 20 kilogram block to a height of 2 meters in 5 seconds. Mario lifts a 30 kilogram block to a height of 1.5 meters in 8 seconds. Compare the work and the power. Okay, let's start with Luigi here. So for Luigi, work will be force multiplied. Actually, this is going to be change in energy, which is going to be change in potential energy because we're lifting the block, we're increasing the height. And so that would be potential energy final minus initial. He's lifting the block, so we could say initially the height was at 0. Okay, so that work is all potential energy final mass height final. So that would be 20 kilograms multiplied by 9.81 meters per second squared multiplied by the height, which is 2 meters. Okay, 20 times by 9.81 times by 2. Okay, I'm going to round it for sig figs, but then when I use it on the next one, I'm going to use my long version. So it looks like we're dealing with 2 sig figs here, so this would be 390 joules. Okay, so that's my work. Now let's look at power. Power is work over time, and we know the work is 392.4 joules. The time was 5 seconds. And 2 sig figs, 78 power, so that'd be watts. Okay, nice. So there's the work for Luigi. There's the power. Okay, now let's compare with Mario here. Same justification that we have going on there. That work will be a change in potential energy. Our initial was 0, so it's all potential final. So potential final is mass times by g times by h. So it is 30 kilograms times by g, 9.81, times by the height, 1.5 meters. So 30 times by 9.81 times by that height. I'm going to round for sig figs, and then I'll use my extended on the next one. So there's the work. So the work of Mario is greater than that of Luigi, and then power is work over time. So we'll take our 441.45 joules and divide it by 8 seconds. Two sig figs, 55 watts. Okay, so interesting. Work of Mario is greater than that of Luigi, but Luigi did that change in energy significantly quicker than Mario, and so his power is actually greater. Nice. Good, good. Last thought, efficiency. So, yeah, you may have heard saying, oh, no, this isn't very efficient. And when it comes to energy and work, we lose some of that to heat and other things. And so the work that we put in is not always the work that we get out. And so we have a way of determining how efficient something is. And it's the work that we get out divided by what we put in, and you multiply it by 100, and that gives you the percentage. That's the percent of how efficient you want it to be, 100% efficient. But usually that's not the case. Okay, so that's efficiency. All right, nice. So next time, we will be moving on to learning target number 3. Yep, learning target number 3 after this.